your chain slings. Do you frequently use chain slings to lift or position loads? In this webinar, we will show you how to properly size chain slings based on tension and reach. We will also share a few case study examples to show you how this applies in various applications and environments. My name is Gisela Clark. I'm the e-marketing specialist at Columbus McKinnon and will be your host for today's webinar. Presenting today will be Peter Cook, our training manager covering rigging, hoist, and load securement. We are recording the session today, and the recording link will be added to our YouTube channel. All in attendance will receive a link to the recording. Everyone is in listen-only mode, so we encourage you to ask questions in the Q&A pane on the right side of your page. We'll take 5 minutes at the end to answer your questions. As a side note, after each webinar, we select one of the questions to be used in our blog the following week. If your question is chosen, we'll send you a Columbus McKinnon promotional item, something cool like a CMCO polo shirt, hat, or work gloves, so send us your questions. Thanks for your attention, and now I'll turn the meeting over to Peter so that we can begin. Peter?
Thank you, Gisela. So what we're going to start off with, we're going to find out what is reach, how to calculate reach, understanding chain load charts, and finding our tensions, and that will help us select the correct sling for the job if we do those steps properly. And then we'll take some questions at the end. If you have any questions concerning this webinar, we will try to answer each and every one of your questions and get back to you. If we can't answer all your questions, I will certainly get back to you after the webinar is completed via email. Just a quick note, any of our webinars are for informational purposes only, and they shall not be substituted for any OSHA regulations or laws or ASME safety standards or any other safety standard out there. And if you have any specific questions, please contact us or consult an attorney. Calculating sling reach. So we need to understand what is reach before we calculate the sling reach. Reach is measured from the bearing point where the crane hook is going to engage on a master link to the bearing point where the hook is going to engage on the load. So that's what our reach is, and that's how we determine what our sling length is. Just other things to consider, we do need to know what the size of the master link, and what we surely want properly identified links. So every component on a sling is properly identified from the chain down to the hooks. Everything has identification on it, and a sling has to have an identification tag and has to be labeled correctly. We have other training that offers how to do this properly in our Qualified Rigger course, which we'll talk about at the end of this program, that if you want more training on that, we certainly can help you out. So we have various types of slings. We have single leg lifts, dual leg lifts, three leg lifts, and 4 leg lifts. And it's usually when we get to the 3 or 4 legs, people have trouble calculating their reach. And because we have to start thinking three-dimensionally, and there's a few measurements that we need to know up front before we can figure those out. So it's usually when I get a call is when someone has a 3 or 4 leg an assembly that they want to lift, and they have trouble calculating their reach at that point. And we'll get into that shortly, and it's going to show you how to do that very easily. So let's start off, and we're going to talk for this webinar a symmetrical load, and that load is 10 foot wide by 20 foot long, and there's a pick point in each corner. And what is the sling reach for a quad sling? And so there's a question. I usually will get someone that calls me with those parameters, and I'll have to ask a couple more questions in order to calculate for them. And so the first one is, do you know the angle at which you want to lift at, what angle those slings need to be at? Or the other question is very important, is how high does that crane hook need to be above the load? And then from there I can figure out the reach. So one of the two I need to know before we start. So let's take a look at a top view of that load that we just have a picture of. And you can see I put a blue triangle on the top, and I put on the top of that load to represent what I'm trying to find, so you can see where I'm talking about, what dimensions that I'm speaking about. And you can see that we're going to take that triangle, and which goes to the center of the load, this is symmetrical load again, is 120 inches. That's half of the 20 feet, 240 inches. And then the upper part of the triangle goes 60 inches to the center of the load, or half of the 10 foot, which is 120 inches. So half of that is 60. And we need to find that diagonal first. What is that length? That's very important. We need to find that before we can go any further. So there are charts that you can reference, and they'll give you the triangle. And so in this case, it shows you the right triangle, and so depending on the dimensions that you know, what formula that you would use. So in this case, we know if you look at that little triangle there, the sides B and C. In this case, B being the height is 60 inches, which we, in this case, would be the distance from the side to the center, and 120 inches is what we calculated to the center, again, from one of the pick points. So if we put those A squared plus B squared is C squared, we will come up with a diagonal dimension of 134 inches. Now that's not our reach. Remember, that is the distance from the pick point going diagonal to the center of that load. That was one of the distances I needed to know. Okay. So we said we need to know one of two questions: what angle or what's the height that our crane hook is going to be. So let's assume that someone wants to rig at a 60-degree angle, and 60 degrees is for any sling would be the best you can do to get the most working load limit out of a sling that you're going to use. In the chain industry, we will only rate slings based on a 60-degree angle. Even if you go more than a 60-degree, we will only rate slings at a 60-degree angle, something that by the National Association of Chain Manufacturers that we have all agreed to, that we'll only rate multiple leg slings at a 60. Okay? So we're going to assume it's 60 degrees, and you can see there's my distance measured from the pick point to the center is 134 inches, which we just calculated. Okay, going back to my chart, so I know what side C is, which is the 134, and I know my angle, which is the 60 degrees, so angle B is what that's called. And if you have a smartphone, I don't know if anyone ever knows this, but with your smartphone, you have a calculator on your smartphone. If you turn it sideways, it becomes a scientific calculator. So you can do this with which amazes me today with the phone technology. So what you would do is you take the 134 and you divide it by 60 cosine. So on your phone or your scientific calculator, you do 134 divided by, and then you type in 60, and then hit COS. That's the cosine, which the cosine of a 60-degree angle is 0.5, and that will give you that diagonal dimension of 268 inches. Okay, so now we're really close. Now we're really close, and that's pretty much how long our sling needs to be. But we need to select something first, which would be the top link. So let's just say in this case we're using a 2.5 by 5 inch, 2.5 inch inside width by 5 inch long master link. All right, and if you notice, look where the tip of where that triangle comes. That's not our reach, right? It goes to the center of that radius of that 2.5 inches. So the center of it, so you take 2.5 inches divided by 2, which is a 1.25 radius, right? And so that's where that is going. So then we need to subtract that out from the master link that we're going to size up. So which is 5 minus 1.25, which is 3.75. So we take that 268, add it to the 3, add 3.75, and so our sling reach to lift that load at a 60-degree angle is 271 3/4 of an inch, or we can just round that up to 272 inches. So if we would need a sling, that's at least 272 inches long. Now, a rigger should we teach riggers how to do this in the field and in our courses, so that they're not grabbing the wrong slings, rigging it up, taking the slings off, putting it back, and wasting a whole lot of time. If they just take a few minutes and do these calculations, they can walk over to their bank of slings and select the right sling the first time to get it right. Now, if you weren't sure what angle to rig at, you just know that, hey, my sling needs to be at a certain height, then you would give us what that height needed to be. So we could instead of having that 60 degrees, we could have had that vertical dimension and say, hey, my hook needs to be X amount of distance above that load, and then we could go and figure out the angles and the reach based on that as well by the A squared plus B squared is C squared, just as we did in the first part. So what is my headroom? Again, we weren't given that dimension. All we were given is the 60 degree. So we need to figure out how much space is that going to take up from the top of my load to the bearing surface of the master link. Much different than reach. Reach and headroom are two different things. Reach was the length of the sling from bearing point to bearing point of the hook to the top of the master link. Headroom is from top of the load to where your crane hook, or the saddle of your crane hook, or to where your crane hook is going to engage on the top of that link. So what do we know? We know side A and we know side C. So we need to know what that height of that triangle is. So B equals the square root of A squared minus C squared. And we will find that the tip of that triangle is 232 inches. We add that 3 3/4 inches to it. So the headroom now is 235 3/4 of an inch or 236 inches high above that load. So therefore now, is that going to take up too much space? Is it, if it's outside, maybe it doesn't matter. So there's two things we need to know. Is the rigging going to work, right? Is that reach going to work? And is it, okay, great, that achieved my 60-degree angle. And then, of course, how high above the load is that going to work? Because we don't want to find while we're in the air that, no, we're not going to clear something or too high. And so then we would have to adjust our slings, which is also going to lead me into, it's going to change our tensions when we do that. And I'm going to lead into that in a moment here. All right, so we know our sling reach, but we got to size that sling for the load, and we'd have to backtrack. You know, depending on how much weight we have. I just used the Master Link example just to give you an example of how we'd have to add additional information into what we found out. But once you figure out what angle it is, if that angle's gonna, if that 60 degrees is going to work for you, then you refer to the chain charts. And here's a sample of our rigging pocket guide that that you can get if you give Gisela your address. But if you look here to the 60-degree, the one to the left, 3 and 4 leg slings. 3 and 4 leg slings are rated the same. You get the same leg sling rating. That's what, again, NACM has determined that's to be the case, and that we can only guarantee 3 legs are going to take the load. Some riggers will say only 2 legs. They're a little bit more conservative, but we're safe with the 3 to 4 leg ratings. And so then you would look at 60 degrees. How much does my load weigh? And you can select your size of sling from there. Okay. So let's just say, for instance, this is a page out of the rigging catalog from Columbus McKinnon. Let's just say, okay, on the quad sling, you chose let's just say you chose a half-inch chain sling, and then what that will do will give you the page number and the components that you require to make up that sling, depending on what configuration, what type of hooks that you make. So from there, you can look and say, oh, what's my master link? It tells you you need a sub-assembly. It's on page 64. It gives you the part number, and then you would look up the size of that master link. It gives you your hooks and your hammer locks and everything you need to properly assemble that sling. If you're going to do it yourself, those are mechanical couplers, and then the only thing else you need is to tag that load. So you can get all your dimensions from the catalog from there. And that's a really nice page. Not sure if people realize we have that, but it makes, I know when I used to run the sling station for Columbus McKinnon, that was great. I could quickly write my part numbers in, size slings, and reference the page numbers. It was really quick for me to design slings for people using that. All right. So those charts are great. And what happens when we're lifting? Sometimes you can lift some heavy loads, and depending on what your angle is, can lead you to a larger chain size or using a small, and that could cost more money to do, or it can have a much bigger sling than you really want. So of course we want to try to get the lightest sling possible for somebody, you know, especially if they're rigging. You know, oversizing is great. That's fine. There's nothing wrong with doing it. You know, the larger the better. But on the other hand, in my opinion, why have something that's too big that you don't need? So you can try to size exact. So what happens? You know, the charts only give, you know, the charts that you see for symmetrical loading will only give 60, 45, and 30 ratings on there, and so you go by that. And that, again, so if I had a 50-degree angle and I didn't know how to calculate sling tensions, what I would have to do is just take the chart and use a 45-degree angle and size my sling that way. And that's what a lot of people do, and there's nothing wrong with that. But what happens when you have existing slings and, hey, that sling's not going to work, but in reality we have a 50-degree angle, and we want to size this sling properly, and so we're kind of what we do is we're kind of off the chart a little bit. And so again, this is from the rigging pocket guide. We use a tension calculator, and basically what it is, based on the angle that you're lifting, we call it load angle factor, or LAF. Okay, so we'll take the weight divided by the number of legs. In this case, if we're using chain, even if you have a 4-leg sling, you're only going to take 3 of those legs. Remember, 3 of the 4 legs will take the load for chain. So we're going to only take 3 of those legs for chain. Now, if you have the wire rope or synthetics, they allow you to use all 4 legs for that. But you never want to go above 4 legs. So some people, oh, we rig 5, 6 legs. No, don't ever go above 4 legs. But for chain, you're only going to use 3. We're real conservative. And, you know, I got to be honest, I kind of disagree with the doing rigging for almost 20 years. I disagree with using all 4 or all 3, and a lot of riggers will agree with me that I would never use all 4. Even when I engineered things with, if I had to use synthetics and wire rope, I would never use all 4 legs. I would always use 3 for my calculation size that way. Just, it's my opinion, but in the chain industry, that is the rule, only use 3. So you take your weight and you divide it by 3, and then if you know your angle, then you just look on the chart here. So if I had a 50-degree angle, I would take that weight divided by 3 and times it by my load angle factor of 1.305, and that would then calculate the tension that I would see in that chain sling, and then I could size my chain that way. And so I'm going to show you a little example from that. Also, if you look to the right-hand side, what if I don't know my angle? Well, I'm looking at it, I'm not sure what the angle is. You can take what's called the S divided by H, and what I like to do for that estimate, you don't have to measure the entire, remember we're dealing with the right triangle, so whether you measure the entire sling and the height or a small portion of it, it's going to remain the same. It's a ratio. So what I like to do is just take, you know, from my pick point, bearing surface of my pick point, and then I go for that S dimension. I use 24 inches because I can remember 24 inches. And then I would drop the tape measure down just like a plumb line straight down for my H dimension and where it meets up, kind of visually look to see where it meets up with that bearing surface of that pick point, and that would be my H dimension. So S divided by H will give me the load angle factor. So if I did S divided by H and I came up with 1.305, I go back to that chart, I got 1.305, oh, it's a 50-degree angle, so I can back into it that way and know what my angle is. So let's look at a...
Peter, before
yes.
we do that, I'm going to go ahead and launch a polling question.
Sure.
Which is, what is chain sling reach? You guys should all be able to see it. If you could please vote on the correct answer that you think. What is chain sling reach? Is it bearing point on hook to bearing point on master? Is it horizontal distance measured between sling legs? Is it diagonal distance from top of the master link to top of the load, or none of the above? Yes, and if you are on an iPad, you will not be able to vote, unfortunately, but you can send me your answer in the Q&A pane if you like, okay? So it looks like, Peter, we are divided 83% think bearing point on hook to bearing point on master. 14% think diagonal distance from top of the master link to top of the load, and 5% think none of the above. Can you share the answer with us?
Yep, it's bearing point of the hook to bearing point of the master. That would be the chain sling reach.
Perfect. Thank you, Peter.
Okay. So here's a case study. This is an actual case study that came in a few weeks ago that I thought that's a good one to use for this webinar. And the load weight, 50,000 pounds. The load has 4 pick points, and the customer wants to use 2 double slings to lift the load, meaning they're not going to use a quad sling. They're going to use 2 double leg chain slings and connect the 2 master links to their crane hook. And in this case, they said the angle will be at approximately 50 degrees from the horizon. And so they knew what their angle was, but they wanted the size. They wanted to be sure that the sling they chose was correct based on 50 degrees, because we're talking about a lot of weight here, and so we want to be sure that we're getting the right sling. They have existing slings in place, and hey, are we doing this right? Okay, so if you're using 2 double slings, basically you're not going to get, you can't take your double rating of your sling and times it by 2. You're still using, you're doing a 4-legged sling, just you're breaking up in 2 separate slings, but you're creating a 4-legged sling anyways. Okay, so still you're only going to use 3 legs of those chains for your weight distribution. Okay, so you cannot use all 4. So there is no loophole by doing that. If I use 2 double slings, that's 2 double sling ratings, and then I can get more rating. No, you can't do that. You still have to size it as a quad, and we'll go through the exercise of doing that. So if I were just, based on my charts, if I were just to look at that and I didn't know how to calculate tensions, I would have to go at, based on, okay, 50 degrees, okay, 45 degrees is what I'll use because that's all the information I have available to me. So therefore, I got to choose a 3/4 inch grade 100 sling because that 3/4 inch is good for 74,900 pounds, and I'm lifting a 50,000 pound load. Okay, but let's try to do that the other way. Let's look at it and let's calculate our tension. So we're going to do a little bit of actual advanced rigging. So you know what? I don't have a 3/4 inch sling, but I'm not at a 45 degree. I'm at a 50. And you can see there the 5/8 sling at a 60 degrees is good for 58,700 pounds, and the 45 is good for only 47, so we're a little short. I found out, hey, we're lifting at a 50-degree angle. Is that going to be good enough? Will that work? Right? Can I use that 5/8 sling? Because I don't have a 3/4. So this is what we're going to take a look at. So therefore, you can play with that angle a little bit. Maybe 60 is too high. I can't use a 60. Can't do it. It's too high. I can get away with a 50. So we take the load weight. The load has 4 pick points. We're using a 2-leg sling at a 50-degree angle. Again, 3 of the 4 legs will take the load. So 50,000 divided by 3 is 16,667. Okay, that's the weight on each corner. And my load angle factor of 50, I go to my chart for my rigging pocket guide, which is 1.305. And I take that 16,667 times 1.305. Which equals 21,750 pounds. That's how much tension is going to be in each leg of that sling. Okay? So if I look, my 5/8 chain sling is good for 22,600 pounds. Now, everyone gets confused here. Well, why are you showing the single leg? Because the strength, the working load limit of that chain is 22,600. Whether I'm getting 22,600 straight up and down or at an angle, it's good for 22,600. Okay, we've calculated our tension, the max loading that chain sling is going to see based on the load we're lifting. At the angle we're lifting is 21,750 pounds. My rigger can then safely say, yep, at 50 degrees, I can use my 5/8 chain sling, and that will work safely and lift that load. All right, so they got it. They didn't have to go out and buy the 3/4 inch sling. They can use the 5/8. Okay, and it's a little bit lighter of a sling to do. So that's another way to go about doing it. So you can see by using just the charts alone, you would have had to go up and go get another sling or purchase another sling to make those lifts. And then by knowing my angles and how to calculate tension, I found out that nope, my 5/8 is pretty good. I'm going to stick with that. So we learned reach, how to calculate reach, and how to calculate tensions. And the two go hand in hand because reach is going to determine our angle, and going to determine our tensions based on the reach that we have. And again, we can use chain adjusters to adjust our reach. I recommend that as well, to have adjusters on your slings. That will help you make your sling more universal. So if you have applications that, hey, I need longer reach in some instances, and then others applications I need a shorter reach, you put chain adjusters on there, and that will help you adjust your reach.
Peter, one question's
Yes.
come in that applies to this slide, and the question is, how come only three of 4 legs take the load?
Just based on tolerances of the chain, things of that nature. Some of the times 4 will take it, but most of the time we can guarantee 3 will take the load. So we don't want to overload the sling, and so it's a more conservative approach. And depending when you lift the load, and I'll kind of throw a shout out to Mike Riggs who did a video on this just at a conference with him, and show that how you lift the load when it leaves the ground, how it renders itself, the tension will remain the same in all the branches. And you'll see you can actually go around and shake the legs of the slings that they'll be in tension or will be in slack. You can actually see that one will be in slack and 3 will be in tension. There could be a time where someone rigs it and only 2 take it, and you can set it back down and say, oh no, put it back down. The rigger will recognize that and lift it up again and make sure that more legs are taking a load. So with that said, through the years within the chain business and the chain industry, the National Association of Chain Manufacturers, giving some tolerance of chain, we're pretty tight, plus or minus a half a link. But what happens when one leg's a half a link longer? it's what's going to happen is one of the legs is not going to see the tension. So therefore, we use 3 of the 4 legs. Okay. So.
Okay, Peter, I'm sorry, one more thing. I wanted to do one more quick polling question, if you don't mind. Okay. This polling question is, how do I calculate sling tension? We're just trying to get a feel from the audience. So, do I calculate it by share of load times load angle factor, load weight times reach, working load limit of chain times load angle factor, or share of load divided by load angle factor? Again, if you all could please vote, that would be great. The question again is, how do I calculate sling tension? By share of load times load angle factor, load weight times reach, working load limit of chain times load angle factor, or share of load divided by load angle factor. All right, looks like a little bit more than half have voted. And it appears that, let's see, it's still coming. More people are voting. Thank you for doing that. It's great. Okay, looks like half feel the first answer. 3% think load weight times reach. About 25% think working load limit of chain times load angle factor, and the last is also 25%. So it looks like we're split all across the answers. Can you let everyone know what the correct answer is, Peter?
Yep, it's going to be your share of load on that pick point times your load angle factor of that angle will give you your tension. So what we did for chain is we took the total weight, it was a symmetrical load, we divided it by 3. Even though we're using 4 legs, we divided it by 3, and then we looked at the chart of what angle we were rigged at, and we times that by our load angle factor will give us the tension that sling chain leg will see.
Perfect. Thank you, Peter.
Okay. One quick, safety note: always use sling protection when possible. When slings are coming in contact with the load or going over an edge. You can see that yellow sleeve there. It looks like a sleeve is engineered edge protection, which is probably one of the best things you can use to protect your sling. It has Velcro on the back. You can slide it anywhere you want on your sling, going around corners and things of that nature. Kevlar sleeves, those are more used for webbing straps and things of that nature. Don't really use them for cut protection. You want, they'll use it for more abrasion or where it could rub up against the load. So you want to put that in places where the sling, when it renders or where it's rubbing up against the load, so that you don't wear the fibers out. And the other best thing you can do is a metal mesh encased in a Kevlar sleeve, because that conforms the load. That's just as good as the engineered, the yellow one, the engineered edge protection. And so those really do protect the sling and keeps the integrity of the sling intact and prevents it from getting damaged. So whenever you can, highly recommend you use edge protection for all your slings. You will save the life on all your slings, and also you will be a much more safe lift by doing so. Okay, that is the information on how that I've had for you guys today for calculating reach and some tensions of slings. And any questions at this time, I'd be more than happy to answer.
Okay, we did get, just so everyone knows, we had some technical difficulties early on, and I really appreciate you all letting me know that you could see the screen and things are moving forward. So, Christy, could you please do me a favor and locate that question that was asked earlier? And if any of the rest of you have questions you'd like to ask, you can do so at this time. That would be great. Let me see. See if I can locate it. Christy?
Gisela, it was asked at 11:01. I can just ask it. So, Peter, the question was, do all chain slings require latches?
Great question, and the answer is no. It's not. There is no regulation in OSHA that says chain slings require latch. You will not see that written in there, and it's one of the most asked questions all the time. We at Columbus McKinnon recommend having the latch on there. The latch, what the latch does is it secures the hook when you're rigging, that it's not going to. It'll help it properly seat itself when you're in slack conditions. It's certainly not meant to hold the load by any means, but it's more for that it's going to hold in place while you're rigging for you and help render that hook. But nothing in OSHA, nothing in ASME V39 that requires the latch on a sling. So then the second part of that, someone will say, well, yeah, but if there's a provision for the latch, then there must be a latch. It does not say that either. again, the law is written the way the law is. It's almost like the way I compare it to people, for some people is the speed limit's 45 miles per hour, and a policeman pulls you over and says, well, 45 is a little bit fast. I'd like you to go 30. Well, no, the law says I can go 45. It doesn't hold up. Even though the good judgment by the police officer that, hey, slow down, it's more safe. Sure, yep, it is to drive a little bit below the speed limit. But so that's it. The law is written the way it is, and it's not in there. It doesn't require it. You will not find it. The only place you find where it says latches are required are for hoists and cranes. It actually will say that in those standards that you must have a latch unless it constitutes a hazard. But for slings, it is not written. And so it's not required, but CM highly recommends the use of them.
Okay, thank you, Peter. The next question is, what would be the best option to avoid a load that can be twisted while we make the lift? Maybe to avoid a load from twisting while they're making a lift.
I'm not certain why that load should not twist. If you're rigging to your center of gravity, well, it's one of two things. One, you want to make sure you're rigged to the proper center of gravity so the load is not moving around. And then the other part of that is tag lines. You want to have tag lines to control that load. Now, if you have a balanced load and you're over your center of gravity, the tag lines, you should not have to have a lot of force to hold that load from twisting. If you are, you don't want someone to be pulled by the tag or injured by holding onto a rope and getting pulled by the tag line. Your instructions are never to wrap the tag line around your arm or let it go if the force seems too great, just to let it go. So when you're rigged over your center of gravity, really any load, you just kind of tug on it a little bit and it'll spin or move for you in that position. So in that case, you want to use tag lines to keep that load into position and be sure that you're rigged to your center of gravity. The combination of those two, we highly recommend always using tag lines. And if you have that, you shouldn't be twisting on you.
Okay, thank you. All right, next question is, can you use a lever hoist as part of a sling?
Absolutely. We had a webinar. There's a webinar on that we did over a year ago. If you go to our YouTube channel, it shows you how to use a lever tool as part of a sling and how to basically the same thing applies. How we just showed you how to adjust for tensions. You need to know that. So that tension formula, you'll need to know. You need to know your angles before you go and do that. So you size the right lever tool. But yes, a lever tool, or we call it. I don't like to use the word lever tool. A lever hoist can be used as a leg of a chain sling. So I don't want to speak for every manufacturer out there, but as far as Columbus McKinnon slings lever hoists are concerned, yes, you can use them. So check with your manufacturer to be sure, but certainly on the CM lever hoist, you can. And there's a webinar on YouTube that you can reference for that webinar. I think it was about a year ago we did it, but it's on YouTube on our channel.
Okay, perfect. Does the pocket guide contain the formula for calculating reach, or what would be the best reference to review the formulas to do the calculations?
We have the Pythagorean theorem on there, I believe. I don't think it takes a step-by-step on the reach, so you would have to reference, the charts that I provided on here, or we'll go back to this webinar and look at it. But you should that chart that I was showing in the webinar, that's readily available. I mean, you could probably Google right triangle formulas, and all that stuff will come up.
Okay, perfect. Latch kits are not required by OSHA?
That's correct.
Correct. Okay, thank you.
There is a letter of interpretation that even states it, and you will not find it written in the OSHA regulation. It's highly recommended by the manufacturers, but you will not find it. The OSHA regulation you need to look at is 1910.184, and you will not find it written there.
Okay.
And I don't mean to say not use latches. That's not my intent. It's just I just want to interpret the law as it is written. And do I think latches are a good thing? Absolutely. Columbus McKinnon thinks they're a good thing. So the more safety you have in lifting, the better. So I highly recommend using them. But when I interpret any OSHA or ASME law, I do not give my opinion as far as what I think it means. If it's not there, it's not written. There is no advisory language in OSHA at all. So if it's not written there, or if it is written, then it's mandatory, but you will not find it.
Okay. All right, we have just a few more minutes left and a couple more questions. Can you use foreleg calculations for wire rope and synthetics because they stretch to take their share of the load?
Yeah, and I did mention that the wire rope industry and the synthetic industry utilize all four legs. The chain does not. The chain industry disagrees with that philosophy, and we take a more conservative approach. But yes, as far as the wire rope and synthetic industry is concerned, yes, you can use all four legs.
Okay, perfect. And the last question for now is, often I see crane operators complain about having to bring hook and block down to adjust lengths of legs. Instead, they like a 12-inch long SGG of matching size, like a chain shortener. What is your opinion or preference if you have a chance and cycle time is not a problem?
I don't have a problem with the longer. We have style A, style B adjusters. Style A is up close to the master link. Style B, you have a length of chain and the adjuster on there. That's fine. That's your preference in certain situations. Yeah, it's a rigger's preference, and we do make slings like that. So there's nothing wrong with having adjusters that are longer for adjusting. Actually, I prefer those too. It just makes it easier. Okay. We also have a hook. It's called a chain adjusting hook that can be put in line with the sling, and those make it nice and clean looking. So if you reference it, I wish I had a picture of it here on this presentation, but I don't. But it's a chain adjusting hook that it's a grab hook and a mechanical link all in one. It connects to the chain sling, so you don't have to have additional hardware, and it goes right in the leg of the sling. So it keeps to me, what rigging should be look neat. If it doesn't look neat, then there's something wrong. But it keeps everything nice and clean looking, and so it's check it out on that hook, or Gisela, we can probably put a little link to that product on there since someone asked that question.
Sure. Okay, perfect. We have one last question from Sean. Anyone who asks a question after this one, Peter will respond to via email afterwards, because we want to make sure we respect your time on this call, not to exceed 45 minutes. So, chain stretch. I know some vendors say 3% and CM says 0%. This comes up all the time when doing on-site inspections, especially when the end user owns several different slings from different manufacturers.
The answer to that question is 0 stretch. Reason being, if a chain is permanently stretched, means it's been severely overloaded, which is it's exceeded its elastic or yield limit of that steel. The rejection criteria for OSHA, is stretch. It doesn't say 3%. Again, you got to interpret the law. Any stretch, remove from service. ASME, any stretch, remove from service. That's B30.9. Columbus McKinnon, any stretch, remove from service. When you see stretch in that chain, if it's permanently stretched, it has exceeded by at least 4 times the working load limit of that chain. So, for instance, if you had a sling good for 7,100 pounds, you can guarantee that that's seen 4 times the loading that it should have, and it permanently stretched that chain. So, therefore, it's no good anymore. You've damaged it. The reason for that property is you're required by ASTM requirements that chain can stretch 20% before it breaks, but it's a safety mechanism. It saved the life of that rigger versus any other chain, if we used carbon chain or hoist chain or anything like that,
yes,
would have broke a lot sooner. So it saved that stretch, saved the rigger's life or saved the load from falling down. But that sling is no longer good. It should be immediately removed from service. No stretch allowed. That's what OSHA says. That's what ASME says. And I'm not sure what manufacturer will allow 3% stretch, knowing that that has been way overloaded 4 times its working load limit. So it's distorted.
Charles just chimed in and said he thinks the 3% stretch might refer to drive transmission roller chain, possibly.
Yeah, I'd have to look up the roller. I don't off the top of my head. There's roller chain specs, so you'd have to look up the roller chain. There are specs for rejection criteria for roller chain.
Okay.
I just off the top of my head, I'd love to. I know where to find it, but I don't have time in this call to.
No, that's okay. Well, why don't you go ahead and proceed with the slides, Peter? We got a bunch of more questions, but we'll have to email. You'll have to respond to them via email because we're running out of time. So, a couple more minutes. Peter's going to wrap this up. So.
One thing, if you like what you seen here and it was interesting, and you want to learn more about rigging, we have a qualified rigger workshop coming up in August at our Niagara Training Center in Buffalo. And for those of you early on the call, Gisela and I were talking about how beautiful it is in Buffalo in the summertime.
Let me tell you, I was at Niagara Tuesday night at the falls. It was so incredibly beautiful. If you come up for a training program, come up now before the snow comes, because you'll really have a fun time.
Well, it's vacation. I mean, it really is. It's a really great place to be in the summer. But we go over all this from rigging gear inspection to calculating tensions. We rig live load, so 50% of the course is actually hands-on, where we're moving things and rigging, and we have the option to certify as a basic or advanced rigger towards the end of that week. We do overhead crane operations that same week, so if you want to do both, if you learn how to operate the crane and rig, which the two go hand in hand, then please come. And then we have a overhead crane and hoist inspection class coming up in July. I believe that's in Charlotte, so learn more about how to inspect cranes and hoist are the classes that we have coming up this summer.
Perfect. All right, and I will take it here from here really quick. So for those of you on social media, we encourage you to connect with us. We love connecting with our distributors, our end users, anybody who has anything to do with us. We have 2 Twitter channels. We have one called CMCO Live, which is our industrial channel, and then we have a CM Entertainment channel for the entertainment industry. You can find all these videos, how-to videos, and all of our safety webinars on our YouTube channel. We have a Facebook page, have a lot of great application shots we share there that are, all of you send to us, and then others we have internally. We have a LinkedIn page, Google Plus page, we're on Instagram, and finally on our blog. And all these icons are on our website in the top right corner. You can just click on them and it'll take you right to the social media channels on our cmworks.com website. So thank you everyone so much for participating. We will be sending you a link to the recording. It might be a little delayed because of the technical issues we had this morning, but regardless, you will get a link, and you will be getting a pocket guide. If you didn't include your address today during the webinar, you can respond via email to me, and we'll make sure you get your pocket rigging guide. So thank you again, everyone, for coming and participating, and we wish you a nice rest of the week.
Take care, everybody.